Alright, so we're doing 7-6 law of sines. Here's the basic law of sines. It says that if you have a side A and the opposite angle of that side, you could also call capital A. You could put A over the sine of A, and it will be equal to side B over the sine of angle B. And that will also be equal to side C over the sine of angle C. So that's what we're saying here. We could set a proportion. Now, obviously you don't need all three. Like, you could cross off this and just use these two, or just these two, or just the first and the last. But you can use this statement of equality to solve for parts of triangles. So let me show you how. Let's take a look here. Do I have some proportion with an angle and an opposite side that I could start off with? Well, yeah, I have this angle 37 and this side opposite of it 3. So I could start off by saying, well, 3 over sine 37 has to be equal to, now what? Well, I'm trying to find side B. Look, and I have it opposite of angle B, which is 68. So I could put B on top and put sine 68 on bottom. And now it's just a matter of solving a proportion, and I'll get my side B. So right now the B is being divided by sine 68, so I multiply both sides by sine 68. Cancels, cancels. And I really have 3 times sine of 68 over sine 37. And I can plug all that into my calculator. So go ahead and do that. Do 3 times the sine of 68. Some of you guys may need to put parentheses here and here. And some of you might have to start with the 68, work backwards. Some of you can go left or right. Just depends on your calculator. They're all different. And then divide that by sine of 37. You might also want parentheses here and here. Okay, go ahead and do that and see what you get. Okay, when I did that, my calculator kicked back the answer of about 4.62. So that's what you should have had for B, is about 4.62. Okay, now this next part says find AB. Well, what is AB? AB is this side. It's opposite of angle C, so we could actually call it little c. Well, in order to find little c, we need to find the angle opposite of it, which we do not have. However, we have two angles here, so you should be able to find that angle. So go ahead, tell me what it is. And you should have got 75, because 37 plus 68 makes 105. And then 180 minus 105 is 75. So let's just plug that in real quick. 75. So now, go ahead on your own. Since you now know that C is across from an angle 75, set it up the same way with the C up here and the sine 75 down here, and equal it to what you already know about the triangle to be true. 3 is across from sine 37. So go ahead and do that, and I'll put the answer up in a second. Okay, I set it up the same way I did the previous problem. Multiply both sides by sine 75, giving me this. When I plug this into my calculator, I got 4.82. Well, I really got 4.815, but if I'm rounding to 2 decimals, I got 4.82. Okay, let's go to the next page. Alright, so this one is not too different, but they're not giving us any triangle to look at now, so we're going to have to draw it. So I'm going to start you off with this one. We'll call this X, call this Y, call this Z. Let's see, we know that side Y is 17, so that's this thing over here across from angle Y. We know that side Z is 14, across from angle Z. And we know that angle Y is 92. Let me zoom in and put that in there. Okay. And they want us to find angle Z. Alright. Well, look at that. We have an angle across from a side and an angle, or a side across from the angle we want to find. Now here's the deal. Before we were doing the sides on top, remember we did I had the A over sine A. That's how we started off. Well, when you're trying to find an angle, you can flip it. Okay, you can not do it this way. Instead, you could say sine A over side A, as long as you put them all on top, or all the angles on top and all the sides on bottom. You can do that, that's fine. And I recommend doing that. I recommend putting whatever you're trying to find on top. Here we're trying to find an angle, so let's put the angle on top. You don't have to, it just makes the problem go by a lot easier. So let's start off with what we know. We have the sine of angle y, which is 92, over the side of angle y, or angle of the side of y, which is 17, equals the sine of z, which is across from the side of z, which is 14. Okay, well, we're going to do the same thing we've been doing, multiply both sides by 14. That's something you should know how to do. These things cross out. And now we have a situation here where we have the sine of z equals this whole thing. And so how do we undo this? How do we get the z all by itself? Well, we have to take the arc sine of both sides. So here's what it's going to look like. When I take the arc sine of both sides, the sine will cancel out over here. And over here, it'll look like this. And look at that, there we go. So we're ready to just plug that into our calculator. So go ahead, plug that in your calculator, see what you get. Make sure you're using parentheses where you need to. I would throw in a multiplication sign here, a parenthesis here and here, a parenthesis here and here, and a division sign here. So go ahead and try that, and I'll put my answer up in just a second. Okay, when I put that on my calculator, I got 55.39, and they want it to the nearest degree, so that means that my answer is just going to be that the measurement of angle Z is 55 degrees. There we go. Alright, now some just simple vocabulary here. When you hear the term solving a triangle, that means finding the measures of all the sides and the angles. So for example, in this next problem, they want us to solve triangle ABC. So that means our final answer should have everything in it. It should have angle A, angle B, angle C. It should have side A, side B, side C. Okay, it should have all that information in it. Now if you look, they already gave us some of this. They gave us angle A. We can plug that stuff in. So A is 33 degrees. Angle B is 47 degrees. Side B is 14. And we should be able to find angle C really easily, right? We have two angles of this triangle. So 33 plus 47, well that's 80. So that means that angle C must be 100. And so now all we need to find is side A and side C. And we could do that, doing the same thing we've been doing this whole time. I recommend that you draw a picture of the triangle though, just to help you visualize where everything goes. So A is 33 degrees. I'll zoom in so I can put it all in there. B is 47 degrees. And C is 100 degrees. And we said that side B is 14. So this is 14. This would be side A. This would be side C. Alright, so all you're going to do here is you're just going to set up two law of sines problems. So let's do one for A and one for C. So we're trying to solve for side, so we'll put the side on top. Start with what we know. We know that 14 is across from angle B, which is 47. Set that equal to A over the sine of A, which is 33. Okay, we could solve that. And then we're going to do the same thing for C. Using the same starting spot, 14 over sine 47 equals C over sine 100. Okay, so go ahead, try and solve those from there. It's nothing new. Okay, multiply the denominator to both sides, get the variable all by itself, plug it in your calculator, see what you get. I will put the answers up in just a second. Okay, when you multiplied both sides by sine 33, you should have had 14 times sine 33 divided by sine 47 in your calculator, which would have given you 10.4. Same thing here, 14 times sine 100 divided by sine 47 would have given you 18.9. Alright, so you can plug all that in to your little final list over here, 10.4 and 18.9. Okay, so I'm going to let you guys free to just try practice number 2 all on your own, and I'll put the answers up in a little bit. Okay, so here's what I did. I used what I knew about side C being across from angle C, set that up as a proportion with my angle on top because I want to find angle B. So sine B over 14, did some algebra, plugged that in my calculator, and I got that B equals 43.9. Well, then I could add these two up and subtract it from 180 and get that A is 38.1. And then I can use that, set over the same original thing, only with the sides on top now because I want to find side A. And put A on top over sine 38.1, multiply both sides by 38.1, and plug that all into my calculator, and I get 12.5. And now I have all the parts. I have all three sides and all three angles. If I wanted to, I could list them over here, but let's move on to the next problem. Okay, this last one is talking about, it's giving us some real-world description, and that's really what this is all about, is using this information to solve real-world problems. So, it says when the angle of elevation to the sun is 62 degrees, a telephone pole tilted at an angle of 7 degrees from the vertical casts a shadow that is 30 feet along the ground. Find the length of the telephone pole to the nearest feet and inches. Whoa, a lot of stuff going on here. So here's what I would recommend. Let's start with what they start with. We have an angle of elevation to the sun that is 62. Alright, so here's going to be my sun. An angle of elevation means that I'm starting at the horizontal ground and some angle to the sun that is 62 degrees. And that means that I have let's see, it says a telephone pole tilted at an angle of 7 degrees from the vertical. Well, let's draw on the vertical first. I know that my line's kind of cruddy, but let's say that's the vertical. It means that it's perpendicular to the horizontal, and that means we have some pole, I'll make my pole blue here, that is 7 degrees from the vertical. Well, think about that. If this is normally 90, and I'm tilting 7 degrees in, that makes this angle here 90 minus 7, which is 83. Okay. So, what else do we know? It says that it casts a shadow that is 30 feet along the ground. Well, here's the pole, and this must be its shadow here. So let's call this 30 feet. And now looking at our triangle, is there anything else that we could figure out? Well, yeah. If I have two angles, I should be able to find a third angle. So 62 plus 83 is 145. 180 minus 145 is 35. So this is 35 degrees. Even though it doesn't really look like it, we have all the numbers in the right spot. That's all that really matters. So I know that this doesn't look like a 62 degree angle, this doesn't look like 35, and this doesn't look like 83, but that's not what matters really. Looks are not that important, it's more about making sure we have all the information in the right spot. So look, now we have an angle across from a side, and what do they want us to know? They want the length of the telephone pole to the nearest feet and inches. Probably should be nearest foot and inches. Well, that's easy, because we got an angle and a side, angle and a side that we're trying to find. Let's call that side P for telephone pole. And let's do this. We're trying to find a side, so we'll put the side on top, which is 30 feet, over sine 35. Set that equal to the pole that I'm trying to find over the angle opposite that pole, which is 62. Sorry, the sine of that angle. Cross multiply, we end up with 30 sine 62 over sine 35. Plug that into the calculator, and we get that P equals 46.18. Okay, well here's the problem, and that would be feet, it is feet, but here's the problem. They want it to the nearest foot in inches, or nearest feet in inches, however you say it. Well, this is our feet, but somehow this represents our inches, but it's just a decimal. So we need to figure out how we can make this into inches. Well, if you think about this, this is 0.18 of a foot, which means that's 0.18 of 12 inches. So we could do 0.18 times 12. And when I do 0.18 times 12 inches in my calculator, I get 2.17. So that means that I could say that the telephone pole is 46 feet and about 2 inches. They just want nearest foot in inches. They don't want any decimal places. And some people will say, oh, well, 0.18 is really close to 0.2. Couldn't I just say 2 inches? Not really, because 0.2 is talking about 2/10 of a foot. And we want to know in out of 12 as a denominator. How many inches do we have? So it's not going to be totally accurate if you do that all the time. So don't just skip to that. But it is a pretty close estimation. All right, that's it for 7.6. I'll put the 7.7 video up next. See you guys next time.